Welcome back to CurioUpdates. In today's episode, we're taking a deep dive into one of the most groundbreaking and futuristic technologies of our time, brain-computer interfaces, or BCIs. Imagine controlling a computer or even a robotic arm with just your thoughts. Fascinating, right? Stay with me as we explore the science behind BCIs, their history, applications, mind-blowing innovations, current uses, challenges, and where this fascinating tech might take us in the future. So, what exactly is a brain-computer interface? BCIs, also known as brain-machine interfaces, BMIs, are systems that establish a direct communication link between the brain's neural activity and an external device, usually a computer. In simple terms, they allow the brain to send commands to devices, bypassing the usual nerve pathways like muscles. It's essentially a mind-to-machine connection. To understand BCIs, we first need to look at how our brain works. The brain is an incredibly complex organ composed of billions of neurons that communicate with each other through electrical signals. When we think, move, or dream, these neurons fire in specific patterns. BCIs are equipped with sensors that detect these brain signals and use algorithms to interpret them into commands for a computer or machine. It's like typing or clicking, but without physically moving a muscle. BCIs bypass the body's normal pathways, making them revolutionary for people with disabilities. The process starts with the brain generating a signal. This could be intentional, like imagining moving a limb. Next, electrodes, either implanted in the brain or placed on the scalp, capture this signal. Then, through advanced machine learning algorithms, the BCI interprets this raw brainwave data and converts it into commands, like moving a cursor on a screen or controlling a robotic arm. The sophistication of these algorithms is key, as they must differentiate between various types of brain signals and noise. There are different types of BCIs based on how they interact with the brain: non-invasive, semi-invasive, and invasive. Non-invasive BCIs use devices like EEG caps that measure brainwaves from outside the skull. These are much safer but less accurate. Semi-invasive BCIs go under the skull but don't penetrate brain tissue. Invasive BCIs require surgery to place electrodes directly into or on the surface of the brain. These BCIs offer the most precise signal readings but come with higher medical risks. To understand how far we've come with BCIs, let's take a quick look at the history. In 1924, Hans Berger made the first recording of brain activity using EEG, marking the beginning of our understanding of brainwaves. Fast forward to the 1960s, and we have Alvin Lucier, an American composer, using EEG signals to control musical instruments. This was one of the earliest examples of a working brain-machine interface, though it was more of an artistic experiment. In 1973, a researcher named Jacques Vidal coined the term brain-computer interface in a groundbreaking paper. He demonstrated that it was possible to control a cursor on a computer screen using brain signals. This was the start of BCIs as we know them. Fast forward to the 1990s, and we saw the first neuroprosthetic devices being implanted in humans. Over time, BCIs advanced to the point where, today, we can control robotic limbs, play video games, and even send messages, all using just our brain signals. Restoring mobility and autonomy. BCIs are already having a significant impact in the real world, particularly in medicine. One of the most promising applications is helping people with disabilities regain control over their lives. For example, BCIs enable paralyzed individuals to control robotic limbs using only their thoughts. These prosthetics provide greater independence and improve the quality of life for people who have lost motor function. One of the most exciting uses of BCIs is for individuals with paralysis due to spinal cord injuries. They can control a robotic arm or even an exoskeleton just by thinking. A feedback loop rewires the brain to interact with these devices, giving them mobility and autonomy. Communication for locked-in patients. Another important use case is communication for individuals with locked-in syndrome, a condition where a person is fully conscious but unable to move or speak. BCIs allow these individuals to spell out messages by merely thinking of letters or words. With each thought, the BCI interprets the neural activity and translates it into written text on a screen. This has been a life-changing development for people with conditions like ALS, offering a way to communicate without moving a muscle. Gaming and entertainment. Beyond medical applications, BCIs are finding their way into gaming and entertainment. Imagine playing a video game where you control characters with your mind instead of using a controller. Some companies are already developing BCI-based gaming systems that allow for this kind of interaction. Virtual reality could also be enhanced, creating fully immersive worlds controlled by the mind. Controlling devices. Furthermore, some BCIs enable users to control their phones, computers, or even smart home devices. Think of changing the TV channel, dimming the lights, or scrolling through social media, all using just brain activity. This opens up possibilities for everyone, not just people with disabilities. Cognitive enhancement and mental health. In addition to these practical applications, some companies are developing BCIs to help monitor and even improve mental health. Imagine wearing a headset that could track your stress levels or help you meditate by detecting when you're anxious and sending signals to calm you down. BCIs could also be used to treat conditions like depression or PTSD, further illustrating their potential to enhance cognitive function and overall well-being. Neuralink. A lot of research is currently focused on expanding the capabilities of BCIs, and one of the biggest names in this space is Neuralink, a company founded by Elon Musk. Neuralink has made headlines for its brain chip implant called the Link, which uses tiny electrodes to record and stimulate brain activity. Their primary goal is to treat neurological conditions like paralysis. In one demo, they implanted the chip into a monkey, which was then able to play video games using only its brain. Neuralink is working on developing high-bandwidth BCIs that could one day allow humans to interact with artificial intelligence or even merge with it. Their vision includes using BCIs to upload and download information from the brain, similar to how we interact with our smartphones or computers. Precision neuroscience. Another exciting innovation comes from precision neuroscience. They have developed a thin film called the Layer 7 cortical interface, which conforms to the brain's surface without damaging any tissue. This minimally invasive technology could be a game-changer for less risky brain surgeries and expands the potential applications of BCIs. Synchron's stentrode. Synchron's BCI presents a unique approach. It is inserted through blood vessels near the brain, eliminating the need for open brain surgery. Their goal is to help paralyzed patients control computers and other devices, making everyday tasks easier and more accessible. BlackRock Neurotech. BlackRock is working on a flexible mesh that can capture up to 10,000 neural signals at once. Their technology is focused on helping people regain control of their limbs and digital devices, pushing the boundaries of what's possible with BCIs. Meanwhile, researchers at other institutions are exploring BCIs that could restore vision to the blind by bypassing damaged optic nerves or help stroke victims regain speech and mobility. Another exciting project is DARPA's Neural Engineering System Design Program, which aims to create BCIs that provide seamless communication between the brain and external systems for military and medical applications. Technical challenges. One major hurdle is the complexity of the human brain. The brain's activity consists of countless signals happening simultaneously, making it incredibly difficult to understand which signals correspond to specific thoughts or movements. Non-invasive BCIs face additional limitations, as the skull dampens the signals, making them harder to interpret accurately. Invasive BCIs, while offering better accuracy, require risky surgeries and carry the risk of infection or rejection by the body. Moreover, challenges related to processing speed and efficiency persist. The brain operates at incredibly high speeds, but current BCIs are limited by the capabilities of their hardware and software to process information quickly and accurately. Accessibility and cost. There's also the question of cost and accessibility. Who will be able to afford these devices, and will they be available to everyone or only the wealthy? Ensuring equitable access to BCI technology is crucial for its widespread acceptance and use. Privacy concerns. Privacy is a significant issue associated with BCIs. Since these devices record brain activity, there is potential for misuse. Could companies or governments use BCIs to monitor individuals' thoughts? This situation necessitates strict regulations to protect users' rights and privacy. Furthermore, as BCIs advance, they might have the capacity to interpret not just commands for movement or communication but also our thoughts, emotions, and intentions, raising additional privacy concerns. How can we ensure that our neural data isn't hacked or misused? Ethical considerations. Finally, profound ethical questions arise regarding the enhancement of human abilities beyond what is natural. As BCIs develop to improve cognitive function or reaction times, we might blur the lines between human and machine. Additionally, concerns arise about the possibility of BCIs reading our thoughts or influencing our emotions. Could this lead to privacy violations or even mind control? These are critical questions that researchers and policymakers need to address as the technology continues to advance. At the end of these challenges and ethical concerns, it is essential for researchers and policymakers to ensure responsible advancement in this field. Doing so will be vital to harnessing the full potential of BCIs while protecting individuals' rights and promoting equitable access to this transformative technology. The future of BCIs holds enormous potential. In the short term, the goal is to improve the quality of life for people with disabilities. However, in the long term, BCIs could become a mainstream technology accessible to everyone. Imagine being able to type emails, control drones, or even learn new skills just by thinking about them. We're also looking at the possibility of BCIs becoming a tool for cognitive enhancement, turning us into superhumans with advanced memory, concentration, and problem-solving abilities. Some experts believe that BCIs could even help us better understand the brain itself, unlocking the secrets of consciousness, emotion, and intelligence. In the next decade, we could see BCIs becoming more integrated into our daily lives, from controlling devices like smartphones and computers with just our thoughts to enhancing our cognitive abilities. Companies like Neuralink are pushing toward a future where BCIs allow us to seamlessly interact with AI and potentially upload our thoughts and memories to the cloud. One fascinating future application is brain-to-brain communication, essentially telepathy. While this might sound like science fiction, researchers are already exploring ways to use BCIs to send thoughts or ideas directly from one person's brain to another. This could revolutionize communication as we know it. And that's a wrap on our exploration of brain-computer interfaces. We've only scratched the surface of what's possible, but the future is definitely exciting. Whether it's restoring mobility, enhancing our cognitive abilities, or redefining human-machine interaction, BCIs are paving the way for a new era of human potential. If you're excited about the future of BCIs and other cutting-edge tech, don't forget to like, subscribe, and hit the notification bell so you never miss an update from CurioUpdates. Thanks for watching, and we'll see you next time for more fascinating content.